We are live.
The broadcast is live. Hi, Eric.
Hi, Adam. I'm Eric. This is Adam, and we are Rubber Duck Engineering, coming to you live.
Unless you're watching on YouTube, in which case we were live in the past.
I was thinking about something that this week is that we experience this like once a week, and so this is a very slow development process of building, I don't know, up to 100 lines of code or something we're up to. But somebody binging on YouTube, you know.
That's a good point. I like to think slow but steady, that wins the race.
So what do we got for our viewers this week, Dr. Barth?
Oh man, I was so excited where we left off last week. Last week we were trying to actually draw the waveform on screen, and we ended up not quite doing it, but you could sort of, do you have it? Do you want to put it up so people can see?
I do. Adam and I were just discussing in the green room that this computer is really only used for Rubber Duck Engineering, and so exactly where we left off is where my computer is.
Yes, this was our attempt to draw a waveform, and I think if you were to zoom in right there on the horizontal line between blue and yellow, that little wiggly wobbly thing, I think, is the sound wave.
It totally is. It totally is, because we looked at the sound data and we decided it was in 2's complement, so there were some really big numbers and some really little numbers, or what looked that big in hex, and then we converted it to signed integers, or signed, I don't know. Anyways, signed numbers, and they were both really little numbers and really big numbers, or sorry, really little numbers and really little positive numbers.
Yeah, I think my theory is they're getting ready to play the guitar.
Yeah, this is just silence.
This is like the hum of their amplifier.
Well, and this is only 16 samples, so we need to add time. And anyways, what should we do first here, Dr. Barth?
I mean, I think we try to just clean up the graphics so we can sort of see what we have.
Fix our bug.
Yes.
So this is our code.
You're very optimistic to think it's one bug.
Oh, I think it's one bug. I think our theory right at the end was that we needed to move to the first instead of line 2, which kind of makes sense because we start off. I mean, for those of you just coming in, this is we're in Flutter. We're using a language called Dart. We're in a custom painter, so we just have a canvas like you would in an HTML canvas. In fact, it literally is when you run it in the web. And we wrote some little helper functions. And we're walking through our sample and doing the left and right channels. And we're doing the left channel in pink and the right channel in blue. And as you were suggesting, I think this may be our problem, because our first point, our y, I think we offset the y.
Right, we tried to go to the middle vertically and
right here.
The left edge.
So one way to fix this would be to not add the y here. And instead just translate the whole thing, which I think makes more sense.
Okay.
Right, so if we canvas it's like save layer or something. Do you remember this code? Oh, my Dart analyzer crashed. Save layer.
I think it's save. I think save layer actually creates like
we don't actually, yeah.
Creates a buffer.
Save. We don't need to create a buffer.
Right. Yeah.
And then we want to canvas.translate. It's probably apply transform or something instead. Oh no, they have a translate. Good. And then we want 0 for the x. Oh, I have no idea what that was. And y range, which I could just type. Y range.
Y range. Oh yeah, y range was the height over 2. Yeah, that's right.
We might need to do that negative, but let's try that. And then we should canvas restore.
Right.
Good measure.
Pop all the transform stacks.
Yeah. Also probably pops our paint. Do we set the paint on the canvas?
I think the paint goes.
Yeah, it goes into the draw path.
Yeah. Oh, the other thing I was thinking is, it looked like our path not only having had a stroke width, but also had a fill. So I wonder if
Oh,
we want to.
so shall we go over to hot reload? Yeah.
Okay, that's looking better. I kind of wonder if when we set the color, is there a separate color for the stroke, like stroke color or something?
I'm sure there is. Like we could do paint dot. Well, I think there's also like a draw rule or something. I haven't done this in a while. Where you can tell it like how you want it paint. Like, do you just want it to stroke? Am I making sense?
Yeah, you're making total sense. I just don't remember.
It's actually probably better if we pull this up on the interwebs or on
Yeah, I just
the
remember
actual docs.
there are like a million options for how you want the thing to look, which will be fun to play with later. But I think for now we're just looking for something basic.
Yeah, let me get a new tab and do Flutter. I will show you great internet people in 1 second. Oops. All right, here we go. Flutter paint class. Everybody see what I'm doing here?
I think if you embiggen the font a little bit.
Embiggen. More pixels.
All right, that looks good, at least to me.
Okay. So if we scroll down here, we can find
Style. I bet it's style.
style, painting style.
Yeah.
Okay. Let's see what painting style is. Here we go. That's exactly what we want. I wonder what the default is. But
I'm sure
we just
the default is fill, because normally you want to like draw big circles or rectangles or whatever, right?
paint style.stroke.
Mm-hmm.
And we just have the one paint, right? Yeah.
Oh.
Why do I see a problem?
Do we need to import something to get paint style? We might need to import Dart UI directly.
Really? I guess that could make some sense. This is what I'm saying is that this is a pretty low-level primitive in Flutter, and I think I just
is it painting style instead of paint? We should go look at the docs.
No, that's cheating. We have an analyzer. No, never mind. Oh no, it totally was. You see the analyzer? It fixed all my things.
It was just one moment passed when you gave up on it.
Okay, so now we're not filling at all. I don't know whether that's good or bad, but now we're just strokes. I do kind of want like a magnification, or what we really should add is time.
Oh, like
this should just be grabbing 16 new samples, right? So.
Oh yeah.
Where we last left our heroes. Oh, that was my other piece of homework that I didn't do. One of our rules of this podcast was that we try not to think about it in between episodes too much, which is sometimes hard. But Adam did give me homework, which was to sort out how to import this file correctly in the Flutter desktop environment, which is a little different from the Flutter mobile environment, which I didn't do.
I think we can roll with it like this. I think this is going to be okay.
So we are reading samples here instead of reading samples on like a timer. Right. So we want it's like a tick provider or something like that.
That's like an animation, right? Like we're trying to animate.
Yeah. Do you remember that code, or do we need to go look it up? We're living off both our memories here.
We should look it up.
For viewers who don't know, both Adam and I spent a lot of time 5 years ago writing some of the first code in Flutter, and then we both moved on to other jobs than typing out Dart all day, every day. And so we've forgotten all the APIs.
So we're a little rusty, you might say.
We're a little rusty.
Okay, so we need to figure that out. The other thing we should figure out then, if we want to tie it to real time, is our wave file gave us a sample rate, but we have no idea what units it's in.
No, we did actually know. I think we
did.
We even wrote like a unit test on this, or if we go to the terminal. See, this is why this one machine has never So I think if I just run this wave example,
Yeah.
we had our sample rate 8,000. Okay, you're right. I have no idea what that means.
8,000.
But if we pull up this again, it's like wave format. There was this thing.
Uh-huh.
Yeah, this random example on the internet of who knows how authoritative it is, but it seems to have not lied to us yet.
It's worked, yeah.
I liked that it had a pretty picture at the top. That's really why I stayed here. Sample rate.
8,000. Well, it gives what we have as an example.
Yeah.
We don't really have
We
to
can also just try. Like.
Yeah. Okay. So let's just try. I like that. So okay. So I think the way to do this then is the sample painter should have take as an argument a duration. So that's basically going to say like where in the no.
Oh, I see. So what I think you want is you want to separate out the state. Like the sample painter should be stateless. Right?
So you just give it the samples.
You just hand it samples and say paint.
Oh, that makes sense.
Somebody else, this stateful widget or whoever holds it.
Okay, so why don't I change the sample painter to take the state in? Right now, it just grabs it out of a global variable, which was a good way to start. But
yeah, what does it grab? Oh, it's samples.
So I'm gonna make a little like a local variable here. Then have the sample painter initialize it.
Yep. I love that you can type now, by the way.
Oh, this is so great. Right. So now we run into fun with should repaint. So I think okay. So this gets back to the like reactive nature of Flutter. So whenever you rebuild your Flutter scene, Flutter compares the old scene against the new scene, and if it matches, then it just doesn't do any work. It only does work if there's a change. And so for a custom painter, the framework doesn't know whether this custom painter is changed.
So this is wrong, actually. We don't need to pass in the samples. We put this on. Oh, never mind. Sorry. Which I see. Never mind. Sorry. So this is this object?
That is the old version of the object. So it's from the previous build.
No.
And then Flutter is asking you the question, is this any different?
So we just compare the samples.
So we just compare the samples, right?
Will Dart do the right thing in terms of it being an array?
Well, I'm wondering if there's well, we could just compare if we just used equals equals to compare.
Yeah.
Like suppose we do this. This won't actually be correct.
Will it be close enough? Like, will it be return false negatives or false positives?
So what this will do is say, is it the same object as it was before? So clearly, if it's the same object as it was before, then
we don't need to repaint.
Then we don't need to repaint.
You're right. It's slightly sticky if it's a mutable object. That could be slightly wrong. But presuming that the outside world is handing us a new object every time, that would have false positives, but that's fine.
Right. So I think we need to make a decision here about whether we're going to mutate the list when we read new samples out of the file, or whether we're going to create a new list and copy data into it. So I think this choice is the second one, where you have a mutable list that you're copying data into, will be slightly more efficient, but will make the reactive UI more difficult to write. Because the reactive UI really wants everything to be immutable. So I'm kind of leaning towards treating these lists as immutable.
Well, so this only does the wrong thing because the default hash function for whatever this thing is, right? The int16 list is just the pointer identity of the list.
Right.
If I presume there must be a generic compare method in Dart.
The problem is a little deeper than that, because if we were to reuse the same int16 list across builds, then even if we did a deep comparison to the list, the new build would have overwritten the values in the old object. And so they would appear to be the same.
Yeah.
So I think we just go with new lists each time. I don't think the efficiency is really going to matter in this application, and it'll make it simpler to write this code.
You really kind of wish that you could express, or maybe you can express this in Dart, that this thing expects an immutable list.
Yeah, so you kind of want to, like, when you receive it, you kind of want to snapshot it and be like you want like a copy on write.
You could also just take a copy, right?
We could take a copy.
We're kind of deep in the weeds here, but
I think let's just go with this. I think it'll be like we can leave a comment that says like the client must not mutate samples after this object.
It's okay if you work on the Dart team and are watching this. You can tell us after the fact, or you could comment live now on Twitch how we're holding it wrong.
I'm sure we're holding it wrong like in many, many ways. Okay, so you think the sample painter should just paint the samples, which I'm totally on board for.
And then we need an animation object or some sort of tick provider that is not just doing based on when we're painting, but it needs to be time sensitive.
Right.
So
I think if we get onto this sample plot widget, I think we want to subclass something like animated widget.
Okay.
I think this will.
We should probably go look at the docs.
Yeah.
I don't remember animated widget well enough.
I think animated widget is trying to help you run an animation.
Rebuilds when the listenable changes value.
Okay.
The animation object. So, like, we could have a listenable, an animation object that ticks once a second, kind of thing.
You don't tell it often to tick. You say, I want you to go from, let's say, 0 time to however long the sound file is.
Yeah.
And then it calls you back like, okay, I want you to produce a frame at this value of the animation. And then we'll go read those samples out of the file and we'll draw it. And then it'll control how often it runs based on how often the screen is refreshing.
Okay, let's just go from your memory and see where we get.
Okay, so I need to look at the docs because we reached the limit of my memory right there. There's a sample code here. I wonder if we should just look at the sample code.
I'm just like marveling. Again, I don't get to write a lot of Dart code anymore, but like the fact that there's just like a Flutter app inside the docs blows my mind.
Yeah, this looked really good. Look, so somebody passed in the animation. Right, so maybe I'll try to model that. Can you scroll up a little bit? Okay, so I'm supposed to make an animated animation.
Passes in the animation and in the build.
I mean, do you want to just copy and paste this into our file and we can start hacking it up?
I'm not immediately convinced this is going to do the right thing, but sure, why not? Let's just.
Okay. Do you want to explore a different approach?
No, let's just grab the whole thing and see.
Okay.
I mean, it's a journey, right? Okay. I splatted the whole thing.
Okay.
So you wanted probably just this thing. So the question in my mind is that. So is it then the responsibility of the animation? Like, who takes this value and converts it to the sample?
So I'm imagining that's what the sample plot widget is going to do. So I'm gonna try to merge our sample plot widget in here with the spinning container widget. Because I don't think we want that. That part looks fine. And we want our build function. I'm gonna keep the old build function there so we can refer to it.
I think we can make this smaller and optimize for the viewers here.
Okay. So progress. So we need to. So in this world, the parent of this widget is controlling the animation, and our job is to get the samples out of the file and then give them to the painter to paint, which seems sensible.
Okay, so we should be like handed a file
Yeah, so if you go up to the top of this file, I'm going to change our global variable to be the wave file.
Okay.
Rather than the samples.
Yep.
I think eventually we won't end up with a. Then I'm going to take this read samples, and I'm going to move it into this widget.
Yep. I'm going to come down so we can see you.
Where did I go? Okay.
It doesn't really feel like it belongs in build, but okay. I mean, it effectively is called from build, so it's fine.
That's a good point. I mean, I think we're just sort of iterating here and trying to figure out.
Yeah. But it feels like whoever gets the like callback to it's time. I think I'm imagining the Flutter animation system like inverted from how it works.
So how many samples? We need to pick how many samples we want.
We did 100 last time.
Okay.
We can change it.
And then somehow we need to take this double and like I think right now the wave file is expecting us to read sequential samples, but we want to say we want to like pass.
We want like some random access.
Yeah.
Which we totally could implement.
Right. So the most natural thing here is to pass like a number of a double between 0 and 1, where 0 is the beginning of the file and 1 is the end of the file.
Well,
Another thing we could do is,
go ahead, sir.
Another thing we could do with time. So like we could change it from a double to a duration. Maybe that's a better thing to do. And then we would ask the wave file like, okay, in 300 milliseconds, what is the next sample?
I see. Another way you could do it is you could just ask the wave file how many samples you got, and then you could say, hey, give me this range, and you could do the range calculation. That's a like raw version than having to figure out what time actually is for the wave file. Although you're right that probably speaking time to the wave file is a better design. It just requires a little more work from us to map from time to samples.
Well, but the wave file is the one that knows how to do that, right?
This also is going to be a little weird in that driving this from an animation, because like we have to tell the animation how long to play. We tell the animation to play as long as the wave file is. Like to make this real time feels kind of awkward.
Okay. Well, we can define the mapping between. So the animation is always going to play from 0 to 1, and then we define how we want that to translate into duration. So we can say that'll be 30 seconds. I think our wave file is.
I see.
Is 30 seconds long, and then we can say run the animation for 30 seconds.
And then we can just think of the animation as being like the progress indicator or the scrub bar or whatever. And how we map that into the actual wave file is up to us. And that makes sense. Like the UI can just think in terms of the scrub bar.
Well, we could literally do that. We could have a scrub bar that is the thing that drives us from 0 to 1.
Step 2, right?
Well, that might actually be easier. That's okay.
Oh, I see. Then doing an animation. Sure. I could imagine that being.
I think you still represent it as an animation in the code because conceptually it's all the same. Like this stuff is all designed so that you can have a scrub bar and animate back and forth and like all these sort of interpolation things we built this way.
Okay, yeah, that's all fine.
So I think we're missing this ability to read at a random offset in the wave file.
I thought we just decided that it's not off. Oh, I see.
At what do they call this? They call this something in audio. The
seek time or something?
Yeah. That's a canonical name. Call seek time. It's fine.
Sure. I'm sure the people who have actually written with audio are just pulling their hair out watching this, but.
Well, that's why they should comment in the chat and tell us what we actually should be doing.
You said something very apropos in the very first episode that has stuck with me, which is that one of the weird things about computer science, which I identify with, is that it's so common that you just dabble in some side field for like 5 minutes, enough to be dangerous and write your few lines of code, and then go back to, your overall problem. So you end up writing terrible. You look terrible to actual experts.
I don't mind looking terrible. I'm okay with it.
Okay. So now we're going to go implement read samples at seek time.
Yeah, do you want to do that? And I'll go fill out the rest of this animation class.
Oh man, you're going to make me code on my own.
Or we can do it together. Maybe it's better if we do it together and the viewers can see it all.
Sounds good. And that way I can cheat on my homework here. All right, so we want reads. This is going to be presumably void. All right, what was your signature here?
I think before we returned it int and then ignored it.
As all good APIs do. There's a long history.
One of the possibilities we could just zero fill at the end and say, if you try to read samples beyond the end of the file, they're all zeros. Which would make sense for the oscillator, right? Because then the waveform would be able to go all the way to the end and then just track out with zeros.
Well, you kind of want the, I mean, when you really kind of want the slider to only, I guess if the thing is shorter than the, like if you imagine that your thing is shorter than 100 samples, you want to be able to both scrub to the end. But when you scrub, you really want to be like minus 100, right? So like, say you're showing a second at a time, right? You want to scrub to -1 seconds.
I mean, yeah. The way I've seen this done before is like there's a vertical bar in the middle, and that's now. And so you can sort of see the wave before now and the wave after now. And so if it's too short, it'll... This is like no end of fanciness in this stuff.
Oh, yeah. I love that we're writing our own wave parser, wave library, because why not? Duration. So this is like now, or duration has both a start and an end, presume?
Oh, I was imagining we would just give it a time point that's like, here's where we are, and then, read this many samples from then. We're sort of mixing units. Like I'd
and we need to seek to now. We need to like fill with 0. Seek to now, and then we do this parser read into. So okay, let's do the easy part with 0. My keyboard stutters a little. Sorry, that or my fingers do, or both. Clear? Wonder what that does.
That looks suspiciously good. That might also make your list 0 length or something.
Yeah, exactly. I can't imagine that does. Making no arguments, that feels like it doesn't. There's no way it could do what I actually want. But I'm willing to be surprised. Fill range, I think, is what I want.
Oh yeah, fill range. That looks good.
I want 0 to samples dot length, and then 0, right? So okay, fill with 0.
Yep.
Seek now. So now is going to be. So this is where we have to figure out what that sample rate means.
Yeah. So I can try to research that over here.
We can. Oh, sure. And I guess I'll write the sort of. Okay. So this is then going to be.
I was sort of surprised to see it as 8,000 because usually it's this 44 number that you see all the time with audio. 44.1 kilohertz.
Was that like 8,000 samples per second? That sounds high.
I bet it's 8,000 samples a second. Yeah. Because if you look at your example where it had the other thing, the other choice was 44.1 thousand, which is the normal. That's the normal sample rate that you see all the time with audio.
I have to go back and look at what our parser takes as a.
Oh, I think I found that on Wikipedia. The sample rate of a wave file can vary from 1 hertz to 4.3 gigahertz.
1 hertz is 1 sample per second.
Yeah, so I think this is just the number of samples per second.
Okay, that's fine.
So this is a pretty low.
We have a seek to after. We really want to avoid seek. Like, this thing is a little too low level. We sort of want to calculate the position.
Yeah, this is not going to be a property of the riff. This is going to be a property of the wave. I think the wave should probably remember where the data starts.
It does. Oh, it calls it something funky. Oh, does it really not? It does not.
Okay, I think we should add that, and then we can just do math on that.
I see.
I think there's an int, right? Like data.
Int beta offset sample start set.
Yeah.
Okay. And so that's right, because we're still reading all this in the constructor, which is wrong. What we can do data chunk. A little bit hackish. Like, anytime you do have a constant in your code, you're like, why?
It's also the current seek position at this moment in time, because we've just read out the header.
Like that. Do we have like a current offset? This is one disadvantage of doing this once a week, is that I forget all the code that we've written.
I think we just add an accessor, like get position or get offset or whatever.
Int get is bytes dot which is what this is doing. But, yeah. Okay. So now we're going back to, okay.
I think you were on line 130. Yeah.
Oh, it's this thing, yeah.
Yeah.
Parser, current offset. Okay, so now we're at the samples offset, and we need int target. This is like now as offset plus now there's probably like an as seconds. I don't recall the duration class at first. Duration just seconds.
Oh, there's actually a really useful field in the WAV file for you, which is called byte rate, which is giving you the sample rate times the number of channels times the bits per sample. Okay.
So I want, but this is still now, I was working on getting the seconds out of the duration.
Oh, okay, yeah.
Or milliseconds would be fine. In milliseconds, sure. Times byte. Where am I? I'm in the parser.
You got it. It's a member variable in scope view.
Okay. Byte rate. So 1 second times byte rate divided by 1,000.
Oh, there's actually a constant in Dart, which is milliseconds per second, I believe, on duration.
This is like the polar opposite of my complaint earlier that I was writing 8 as a magic constant. This is like,
do you really need to know
you don't need to
how many milliseconds per millisecond there
to write? But sure. Okay.
I think you need. You're gonna want the squiggle divide here because you gotta get back to an integer.
And we want to truncate.
Yeah.
Because doesn't this do? Oh, that's comment in Dart. Maybe that's in JavaScript. It does the slash. I don't know. Somebody else uses the slash as a squiggle.
Yeah, you're sort of picking millisecond resolution here. So I guess it's okay.
As opposed to.
I mean, like nanosecond, right? That's fine. It's just a choice. Like I just think it's useful to recognize what choices we're making.
Okay. Now is offset. And so now I want to seek to offset. That ended up being in the middle of a sample. Like, does the parser know? It doesn't. The parser doesn't know like the structure of the samples. So here again.
Oh, we need to round, right? We need to round down to the alignment somehow.
Yeah. So like you want this to be
there's
modulo.
a block. There's another property of your wave file just for this, which is the block alignment.
What does the block alignment do me?
That's the number of channels times the bits per channel. So if you the number of bytes for one sample, including all the channels. And there's a comment in the spec that says, "I wonder what happens when this number isn't an integer." That's a good question.
Let's see. Oh, it's block align.
Oh, sorry, block align.
Seek to offset now as offset. We're really flying blind here.
Oh, I think modulo is not what you want. You want to you want to take now as offset minus equals now as offset modulo block align.
Now as offset.
Because you just want to trim off the remaining fractional.
That would just set you back one.
Well,
right.
So you've computed some byte offset that's like in the middle of a sample, right? And you want to like back up to get to the beginning of that sample.
But you still need to use modulo here, right? Now as offset minus equals now as offset modulo. Whoa, what happened? I pressed a button. Block aligned. Make sure our offset is at a sample start. Make sure our computed offset. Okay. And now we seek to offset. We'll implement in a second, and then we read into. Great. Is seek to offset redundant? Should it just be seek to? Or whatever, that's fine. All right, so seek to, but the problem is that this is going to be, we have to add our sample start. What do we call it? Sample start.
Well, you already did that on line 144.
Oh, you're right. I think it makes slightly more sense. Like this doesn't belong in here.
Yeah, I agree.
Because it doesn't need to get like moduloed. Okay. Does this look reasonable to you?
I think that's great.
So you're right. We could do microseconds here instead. And since we're sampling so freaking often.
Yeah, you're sampling 8,000 times a second, so milliseconds seemed a little bit coarse, right?
Per second. Hold. The microsecond bidder. Okay. Now we just need to do seek to, which is avoid seek to often offset. Int offset bytes. Set position sync offset.
No, seems legit.
Avoid using braces and interpolation not needed. Yeah, fine. Okay, wait.
He'll acquiesce.
Okay. So we did that.
Okay.
Maybe it'll
great.
work. Theoretically, we didn't test it.
We could write. You want to write a test for it?
No. Let's skip ahead to the pixels, and we can come back.
Okay. Right. So here we are in our my stateful widget state. What do we want to call this? Animated sample plot.
Animated sample plot. Sure. Well, I see. So animated sample plot. So that's instead of a sample plot, because the sample plot. Why isn't the sample plot already animated? I don't quite understand what this is different.
This is going to drive the animation. The sample plot just you give it a point and it'll draw something for you. This thing will decide. It'll like run the animation.
Yeah, just call this like wave player or something. I don't know.
Okay.
Wave something, whatever.
A wave with no E because we're cool.
We're hip to our formats here.
There's some like crazy editing going on with this live.
No hands.
Picker provider state mixin. All right, we got that going for us. Okay, so I think our wave file is about 30 seconds long. So I'm going to just set this to 30 seconds just to go with it. So over the course of 30 seconds, we want to play, right, and then we want to remember our animation.
Oh, we could just ask the wave file.
Oh yeah, do you want to ask the wave file?
Yeah, let's just ask the wave file. Or just write it as though we're asking the wave file.
Okay. So I'm going to give this an obvious name like G underscore, so we can remember that this is our global variable.
We need to pass the wave into this thing.
Yeah, we're getting to the point where we can actually start to do that. So the duration here is, I'm just going to go with it in a global variable. We could refactor it.
That's fine.
Duration.
Well, why don't we just pass it in? Like, what's holding us back?
Okay, let's do it.
Like, even if we had held in a global variable, this thing can think it got passed in, and we can pass it in from a global at a higher step, higher level.
Oh, I'm hip to it. I think it's like this. Right?
But why is that in the stateful widget? Shouldn't that be in the state? Oh, no, you're right. But then I guess we have to create state with that, with the wave file?
From our point of view, the wave file is just a bunch of, it's like a database. Right? We just get past it. We don't ever mutate it. We just read things from it.
Oh, I see, because the state has a pointer to the widget anyways. So we don't have to pass things between them.
Right. So we want to set up our animation as, oh boy.
I apologize, Internet. I realized that Flux was on and was telling everyone to go to bed.
Is it bedtime?
It is kind of my bedtime. My kid gets up really early, but no, we now are not staring at sepia-toned Visual Studio Code.
This is so beautiful. Okay, this is totally from memory, but the analyzer didn't make any squiggles, so I assume that means I typed it perfectly.
Well, we have undefined name wave.
Well, we need to add the duration getter to the wave file. That too.
This thing. So this is, but this isn't right.
This is right. We just need to pass the wave file to the sample plot. That's fine.
Why don't we just pass the samples to the sample plot?
Because it's the thing that knows how to. It's the thing that's getting provoked every time there's an animation. Every time the animation ticks.
I see. The state isn't told about this tick provider. There's no callback sent to the wave player state.
You could do all this in fewer classes. It's just this was how the We just started from this example from the website.
Yeah, that's fine.
Which is how it did it.
All right, so we have to teach the wave how to figure out its duration.
Yeah.
Which is fine. It probably knows that in a field, or we just divide the.
It's totally gotta know how long it is.
It appears
it's got everything.
Okay.
It's got the block of line, you know.
I mean, we can compute it trivially, right? We just do int, or you want duration?
Yeah, I wanted a duration.
It's duration, and this is then it's like
what's going to be the subchunk 1 size, which is how much data we have.
I think it's subchunk 2 size, actually.
Oh, subchunk 2 size, yeah.
Subchunk 2 size divided by bytes per.
Divided by byte rate.
And that's per second? Okay.
No, that'll tell you how many samples you have.
Yeah, that's not what I want.
Oh no, sorry. If you divide by the block of line, right? If you divide by the byte rate, you'll get how many seconds you have. Right, because you'll say how many bytes do I have, and how many bytes divided by how many bytes per second tells me how many seconds.
This is not how you make a duration.
This is fine, except now we're dealing with like floating point integer issues.
Double cannot be assigned to. Oh, I had assumed that. Okay, fine. So we actually want. What precision do we want?
I guess microseconds is what we did before.
And this is times micro. This is actually where these make a lot of sense. Duration. Did I do this right?
I think you want to put the multiplication at the very beginning, because in the end you want to do one of these squiggle divides. So you want to get as big a number as possible before you do your divide.
Why are we doing a squiggle divide?
Because you want to end up with an integer number of microseconds.
Subchunk 2 size. Okay. Seems reasonable.
Mm-hmm.
The compiler doesn't hate it, so. Are we just going
to try it?
Should we just go see what it's been hot reloading this whole time?
Yeah, I'm kind of hoping the line is going to dance. By line dance, I mean it's going to show us a beautiful error message.
Listenable is not equal to null is not true. Why is our animation in sample plot null?
I'm sure I screwed up something.
Well, when we create this sample plot, we don't pass a listenable, or we don't pass an animation to it.
Maybe animate was the wrong thing. But this thing here I wrote with a tween around line 123 was really sketchy. I just sort of guessed at what it was.
Hold on. Tween duration begin.
We should just find an example. We should go to the tween docs and say, like, if I have that animation controller and a tween, how do I make them have music?
Is that the official term?
Yeah. Well, I guess we're trying to make everything have music, but
controller drive.
Oh yeah, there we go. So
what does it mean to drive a tween?
I don't know.
Does it get a steering wheel?
It doesn't crash. It drives.
Did you create the animation API, or was that Ian?
The animation API went through like 6 different iterations. Neither of us were the original author.
It was a group effort.
It turns out animations are really tricky. My favorite thing, this is a side
Please.
thing. In Flutter, there's a thing called a train hopping animation. So this is when you have an animation running in one direction and another animation running in another direction. And what you want is the animation that starts off, oh my God, this is not mirrors. It's going to really drive me crazy. It starts off going this way. And then when this train comes, it hops onto this train. And Darn it. And then this train continues. Okay, I'm gonna have to do it with my eyes closed so I can see it. It starts off in this way, and then this train comes by, and then the value like hops onto this train and continues back. So it's like a boomerang. And Ian Hickson named this the train hopping animation, which like is the only way I can remember what it does.
Here we go. I'm pretty sure we have like animated GIFs in the docs now.
There should be like a little picture of like somebody riding on top of a
Oh,
train,
I feel-
like hopping over and like going the other direction.
I know this. I know we have animated GIFs of the various animations somewhere.
This one is really obscure. Like, I think we needed this because we were doing hero animations. In material design, there's this funny thing where the widgets can like pop out and like animate across your pages and then drop down. But then there's a problem that happens that if you're in the middle of a page transition and then you decide you don't want to do that and you back out of it, then it's got to like keep going to the point where the reverse animation would pick it up and then put it back where it started.
Yep. I don't know if it was for that, but I'm really sad that we don't seem to have an animated GIF. But viewers at home can find it. I know it exists somewhere on the internet. Okay.
So did we
back
fix
to-
our error?
Who knows? We talked about train hopping animations. I have no idea. I think our listenable is still null, although once we hit an error, it might not recover. Animation drive. Let's do a hot restart, which gives it a bigger prayer of recovering.
It's also possible that those two lines of code I wrote were equivalent and we still have a null animation somewhere.
I mean, we could use the power of debugging. So this is an int state, right? So this should run when we do a hot restart. Restarted application. What is our assertion error here? Following assertion, failed assertion, listenable, not null.
So this breakpoint didn't get hit, which maybe... Oh, are we even using this thing? Oh, we never used the wave player.
Oh, details.
I think that's our problem. Right, we just stuck the sample plot directly in there. Okay, I changed it to a wave player.
Okay, so I saved. We're still going to need a hot restart because we're initiating state here.
Did you take the breakpoint out?
I did. Child must be laid out exactly once. That makes no sense. I think I got it confused. Okay. Restarted application. I don't know why it takes 6 seconds to hot reload. Maybe because my poor machine is just... I have fans blaring on this poor little MacBook Pro as it tries to stream and run.
At some point, you just like pile on the ice cubes.
I need to get like a liquid cooling mount for my MacBook Pro. Okay. Getter duration was called on null.
Oh, we never passed in the wave file.
Oh, details.
Okay. There you go. I put a wave file in.
Is that actually assigned in our little G wave? Did we save that off? We did, but why do we have a problem for? Oh.
Oh, okay. I'll fix that.
Oh, well, this is because we declared it a local, shadowing our global.
Oh. Let's not do that. Okay.
Do you remember?
We should probably go through all these analyzer warnings before we try running it.
We wrote a lot of Flutter before the analyzer worked. But
yes, well,
I don't know how we did that.
That was before we were rusty at it.
True. Okay. Whoa.
Oh.
We're
Okay.
white. Blank white. All right. Let's reload here because we may. And I keep using hot restart instead of hot reload because we're dealing with state and state initialization, and I want that to run.
Yeah, we're like messing with our global variables, which we shouldn't have.
Okay.
Okay.
So it's not updating though.
Yeah, I was kind of hoping it would move. Okay.
Mhm. So this is where we, I think, do some printf debugging. Like, what should be getting called
Well,
when our animation ticks?
the painter should be getting called. We could start there.
We can also add.
Oh, you know what would be really good? In the wave file,
Mhm.
where we read at seek time, if we just print out what time we're reading in there, then we would ideally see that to, print out a lot.
Assuming that duration prints.
Sure.
I don't know why. What's wrong? Suspected identifier? Oh, I see. The analyzer was just this again. I'm overloading this poor machine, and so the little analyzer, whoa,
that was cool.
What, pray tell, happened?
I don't know, but it looks awesome. Oh, maybe
it also updated. Is it? No, it's not updating.
Can we see the?
Whoa, we're seeking.
What?
We're seeking.
Beautiful. But it's not redrawing. Maybe we messed up on should repaint. I bet we messed up on should repaint.
I mean, we just passed true.
I think we're supposed to say we should repaint if they're different.
Oh, did we repaint if they were the same?
We decided we should repaint if they were the same. So we did all this work.
The viewers at home didn't get to see the bug, but
oh, sorry. If you go to line 80. Yeah, sorry, I shouldn't have done that. This previously was an equal sign like that, which said we should only repaint if they're exactly what it was before.
Which should never be true. So we were doing should repaint false. Okay.
And now we're saying we should repaint if they're different, which is when you want to repaint because you want to show the different thing.
And we just save it, and it should just now. Now it seems to be going super slowly through our CD.
Oh my gosh, that is so amazing!
We did it.
It's beautiful.
I'm kind of proud of us.
I think this is great.
Like, we got all the way from a wave file. I mean,
this was highly
we even
scripted.
did it in time.
Yeah, to exactly happen right at the end of the show.
I'm quite proud of us. I have no idea what I'm seeing. I think it's going through relatively slowly. Like, if I look at the printouts, you know what we should do? Well, first of all, I should remove this. Okay, I need to go.
Well, we could up from 100 to a lot bigger.
Well, we're going to use the power of Flutter to actually throw some widgets on screen, but instead of printf debugging, right? Like, we could just show now on screen.
Oh,
it doesn't take any effort.
this
we're maybe in a UI framework.
this is true.
Unless we did something crazy about like our size block expand, but like what? We're just going to put this in a column and put now below it.
Yeah, I think right in the sample plot, instead of just returning a custom paint, you could return some more stuff around it.
Yeah. So if I click on this little thing and wrap with a column, and then I could just put a text.
Yeah, so I think we want to expand the custom paint, right?
What were we expanding the thing outside of it before? That's fine. We can, yeah, that's fine. We can expand the custom paint.
Expanded.
And then we do text of, we want, where is our wave file? Oh, wave dot.
We just want the, so we can pull out the duration here. So like duration now equals the part side.
And then we just like want now to string. I think I have to manually call toString there, don't I?
You could, yeah, you either manually call toString or do a string interpolation.
True. That's actually probably cleaner.
Well, you probably want to say like offset colon or like whatever.
Sure. Why is it complaining? Okay. If we go to this, where is it? What did we screw up? Right, let's do a restart here. I love that. I hope it's not like having hugely leaked memory, but I love that the exact same application that we launched last week is still the one. We have not restarted. We have not dealt with Xcode. We're just injecting new code. Whoa.
Oh, that's really great. We need to do something with the cross-axis, like.
So what was
it's cool. I like it. We we want it to get big in the cross-axis.
Why was it doing it? Because I think we were in a sized box expand before. I think the parent is sized box expand. Right? Do we need to play that trick again for this guy?
No, the column can do all this. I really don't remember all the names, but there's something like cross-axis alignment fill, which says I want you to be big.
And it's waiting for your characters to come through the tubes.
Oh, sorry, they're stuck in the tubes. You may need to do this because I don't have the analyzer to actually figure out what the.
I don't think it's fill. I think I've done this actually recently. Crossing. Expand. Maybe.
So in a column, the main axis is up and down, and the cross axis is side to side. And so we're trying to say, be as big as you can, side to side. Stretch.
I wish to buy a stretch. I love it. It's not right, but I love it.
Did it do anything?
No. And I'm going to try a restart, but the restart should not change the behavior here, unless we've screwed up somehow. Oh.
Okay.
So why did it not do it on a reload, but it did on a restart? What did we change?
I think your computer is just lagging a little bit. Like I think if time had gone by, it would have done it.
Whoa. What did we do? Shortcuts. Keys not empty. Focus manager. Oh, this is probably just desktop.
I see. You're directing key events to it that it doesn't understand and it's getting mad at you.
Yeah. And this is the, again, Flutter for desktop, we're living on the bleeding edge here. It's fun to play with, but it's not something that, hundreds of thousands of people have shipped or whatever yet. Okay.
Yeah. So
I think this is like it. Like we can call it for the night.
Yeah, I think this is great. I think maybe in the next episode we could try to do the Fourier transform.
Yeah, this is so cool. We could even pretty trivially throw a little scrubber on here, as you suggested. Because Flutter actually should be pretty good at that, about having an interactive animation, right? Two sources of truth.
Yeah. And I also think we may want to look at bigger sample ranges. I think we're zoomed in really close on the wave function. Because if we're doing 8,000 samples a second, and we're only putting 100 of them on screen at a time.
I just want to do that right now. I know we're over time and all, but that just sounds like fun to me.
Whoa!
It looks so real.
Yeah, so now I think this is enough to maybe to do with the transform on. Because you can sort of see that it has some frequencies to it, right? I don't know. Oh,
this is so cool. I just love that we have built up from first principles here. Well, first principles-ish.
From first bytes. RIFF. Okay, now what? But all that random, all those random fields we read out of the wave file and just shoved on the object because we didn't know what to do with them.
Sure.
We used a bunch of them.
We did.
Yeah.
I mean, we're going to use all of them, and there's so much we could clean up, like not parsing in the constructor and maybe having some sort of samples object or handling different wave files. If we shoved a different wave file on this with a different sample rate, it would just fall over. I think. This is my prediction.
It might draw even more awesome pictures. You never know.
Maybe this is how the first visualizers got. It's just by bugs.
It's not a bug, it's a visualization.
I wonder what that junk at the end of the file is. Did you have the animation set to loop?
I did, yeah.
Okay. But like it has this junk where it's like super negative on both channels.
Oh, I think we actually see that because when we're reading the samples, we don't stop at the end of the chunk. We just read whatever that is in as that's totally samples.
Oh, you think that might be the like extra chunk or that might be.
I think there's something at the end of the file that's some kind of actual binary data and not part of the wave form. But
that
the way
totally be. Yeah, right there.
The way we've written the code, it'll just read it and assume it's samples.
Okay.
There you go. Bugs.
Anyways, Adam. Oh, you and I are having this whole conversation, and the internet can't actually see it going by. But, anyways, to go back to our faces, this was super fun, as always. Do you have any more thoughts for the internet?
I hope you like our color choices.
Actually, before we go,
horrific yellow.
Before we go, I want to tell my story. I didn't get to tell my story of how I spent my entire evening tonight. I recently had a little bit of work done on my place, and they dragged an Ethernet cable, and I spent like the hour before the show frantically trying to move my internet setup from one side to the other, and then I spent the longest time debugging why my PC could see the internet, but the hubs being connected said the cable was no good. And it turned out,
yes,
it turned out that the hubs were like going to the little mesh network, and like mesh network was like hopping across. You know, the internet was like magically fixing itself across the mesh network.
That wasn't the internet was designed for. Like it should be resilient to things getting blown up and stuff like that. Like you realize the dream of the internet in your own home.
And somehow we're there in 2020. Anyways, that was my sob story, which maybe wasn't that sobbish for the night. Anyways, this was a lot of fun. Thank you. Any final words before we leave the viewers to their evenings?
No, I'm looking forward to next week.
Yeah, looking forward to it. Thanks, Adam.
See you.